Hello, what's going on? Now we are here to do a somewhat interesting question. I mean, this question, when I look at that, it's a bit different to the questions we've done. So I think it's going to be interesting. More learning value, right? More challenging. Okay, let's look at the question. All right. Now, according to this, pyruvic, okay, maybe I'm not pronouncing those names properly, but pyruvic acid is an organic molecule formed as a byproduct of anaerobic respiration of animal cell. This is, I've forgotten all this biology stuff. This is the process used by cells to extract usable energy, blah, blah, blah. When there is a limited supply of oxygen cells, so they talks about the anaerobic respiration. Uh, that happens when there is lack of oxygen. The structure of the pyruvic acid is shown below. So this is CH3 groups. There's a carbon here. There's a carbon here. So it's an interesting one, isn't it? So it is what? This is like a CH3, CO. Oh, that's so much interesting. So interesting. COO, and then you got CO carboxyl functional group like so. That is the pyruvic acid. The pyruvic acid is reduced to lactic acid. Okay, so they are saying pyruvic acid is reduced to lactic acid in a later stage in anaerobic respiration. So what's the lactic acid? Now this wasn't given like that. So this is how it was given, lactic acid. All right, in this case, what do you think? You have a carbon. It's better to draw them as they are, so then you can visualize it easily. Okay, so what happened here is, see the difference. So only difference here is CHOH here. This is, there's a carbon here. Now instead of that, you got the ketone group. Oh, so what is the question is asking? What reagent or set of reagent could be used to convert lactic acid into pyruvic acid? Oh, from all this part, going back, man, going back. So lactic acid. Now look at that. So this part is like a secondary alcohol, isn't? Remember CH and OH? CHO is secondary alcohol. So this is secondary alcohol. All right. So that part becoming a ketone group. Oh, that's simple, man. So what you need to do in order to convert that part into the other, you need acidified potassium permanganate, KMnO4, potassium dichromate, acidified potassium dichromate or potassium permanganate. I mean, or you could write H plus slash MnO4 minus as well. Set of reagents. So question asking reagent or set of reagent. I mean, I would have look. Why should it say this? Sulfuric acid was considered and potassium permanganate. They are the reagents you need to know. Okay, write an equation for an addition reaction that could be used to produce lactic acid from another organic compound. Hmm. Okay. Now, what is this question asking you? Hey, come up with the addition reaction so that come up with a compound that is going to undergo addition reaction so that you can make this what lactic acid. Well, I would say that's not a difficult. What is here? So you have a carbon here. So as you can see, you are addition reaction. Okay, think about addition reaction. What type of molecules undergo addition reaction? You know that it has to be alkene. Alkene. All right. Now you want to come up with the alkene so that it's going to become you. Alkene. You can come up with the alkene. You need to add alkene. You can easily add water here. So if you had something like that, CH2 double bond CH and C, that's the molecule. I mean, then you add, what could you do? You can add water to this one, then you can simply make that molecule, can't you? So look what will happen when you add H2O. Uh, I'm doing the first reaction, okay? Even though this is part C. Adding water with the presence of H3PO4 phosphoric acid, you know that, then water is going to get added 300 degrees Celsius. So that becomes CH3CH CHOH CHOH and COOH. So that is the one. Okay, so they want us to write an equation. So what you need to do, write the semi-structural formula CH2 CHCOOH plus H2O gas steam, presence of what? H3PO4 at 300 degrees is addition reaction. Then you are going to get what? CH3 CHOH COOH. Now, how did I know that? Okay, how did I know that I had to add water? In order to do that, what this is what I did. I mean, addition. Then I thought it's alkene, so you have to have carbon-carbon double bond. Where would you have carbon-carbon double bond? Yeah, look. This is my thinking. I'll show you what my thinking. They are saying what? They are saying, hey, do addition reaction. In order to do addition reaction, you need to have alkene. You need to have carbon-carbon double bond. So you cannot have carbon-carbon double bond here because then there are too many carbons, yeah? So that is why I put the carbon-carbon double bond here. All right? So that is why I did that. Then I know that what could we add to what do we need to add to introduce OH? The water. That is how I did that. Yeah, I know it's a little bit tricky. Yeah, it's a little bit tricky. Okay, that question is done. All right, so we'll do question 8 in a moment. See you soon. Bye.